Hi, math students, it's Miss Carol, and we are still on Unit 5. We are still talking about the flu epidemic that is sweeping through this high school. We're now on lesson 24, though, and at this point we're going to talk about dilations of exponential functions, and we're considering a situation in which there are actually more high schools now being affected by the same flu virus. So let's jump into these 6 questions. Question 1, the function f of x equals 2 times 5 to the x plus 6 power, which is what we came up with for lesson 21, is shown on the graph. It has been defined to model the spread of the flu in one community high school. However, 2 additional schools in the district have also been exposed and can be modeled in the same way. The district superintendent wants to create a graph that represents the spread of the flu in all 3 schools. This can be done by transforming f of x using a vertical dilation. Which mapping statement is needed to transform f of x? Okay, so in this scenario, we are looking at, instead of 1 high school, we've got 3 high schools with the exact same thing happening. So what we're going to end up doing is multiplying this by 3, multiplying our initial function by 3. So if we go back up here, we can see that that initial function is 2 times 5 to the x power plus 6. There's still going to be 5 students affected each day, and at each of those schools, still 2 students are going to come back and affect other people, and each of those students would, or each of those schools on their own would have that k value at 6, that horizontal asymptote at 6, and an initial value at 8 for each of those schools. But since we're multiplying it by 3, our function is going to be mapped like this, where k is 3. We're going to multiply kind of everything, every term in that function by 3. So what that's going to look like, I'd like to show you on a graph first. Let me go back to the equation. What that's going to look like is if I just take 3 and put the entire function, initial function, in parentheses, and then I multiply it by 3. So what we would have is 6 times 5 to the x power plus 18, okay? And the graph of that is going to look like this, where our initial value, if each school is 8 and we have 3 schools, then that makes sense that our initial value would be 24. If our asymptote for each school was 6 and we have 3 schools, then where our asymptote is going to move up to y equal 18. And then it's going to continue to spread from there. Okay? So let's go back to these questions. We identified that we were multiplying the entire function by 3. In the mapping statement above, what is the value of k? And so we identified that because we're dealing with 3 schools, we're multiplying it all by 3. Okay, what is the initial value of the image of the dilation? Okay, so this is like the post image, and what we decided over here was that that initial value is 24, which is 3 times 8. So again, that totally makes sense. And I'll just type in 24. Okay, so in the answer key, this one is wrong, but I'd like you to go ahead and type in the right answer, and I'll make sure and grade it correctly. I guess it'll be kind of how I know you watched the video. So what is the horizontal asymptote of the image? Oh, you know what? Well, let's see. Maybe what I'd like here is, let's put the horizontal asymptote of the dilation. So they're asking the horizontal asymptote of the image. Let's see. Let's make it so your answer is not right. So the horizontal asymptote of the image, which was the pre-dilation, right, happened when we weren't multiplying by 3. And so that asymptote was happening down here at y equals 6. The horizontal asymptote of the dilation was y equal 18. So let's go ahead and we're going to type it so you're not going to get it wrong, but I think it's kind of a misleading question for sure. I would give either answer credit, but let's go ahead and do y equals 6. Okay, I couldn't figure out why they were going for y equals 6 on that, but I think I'm finally there. But I think a better question would have been the horizontal asymptote of the dilation. All right, last question for lesson 24. The daycare center has also been exposed to the flu. The function that models the spread of the flu in the daycare center can be determined by the mapping statement f of x mapped to f at 1/2 x. All right, so let's see if we can graph that and figure out what that would look like. So essentially what they're doing is for anywhere that there's an x in here, they would be dividing that x by 2. Okay, let me go ahead and we're going to have both of these show up on the graph. 2 times 5 to the x plus 6. Okay, so now both of these are going to show up and you'll be able to see what happens with each. Hopefully they'll both show up. Okay, so the daycare center is in red and the high school is in blue. And what's happening, they both have that initial value there of 8, okay? And they're both going to have that horizontal asymptote at 6, but it's going to take longer. Our x values are bigger for the same values of y. So it's going to take that daycare center longer to get to 16 students sick, or longer to get to 24 students sick than it does for the high school to get to those same values. Okay, so what we should be typing in here is that the flu is taking twice as long because we have x over 2. I'll spell flu right one of these days. To spread in the daycare than in the high school. So the daycare image is a horizontal dilation of the original image. Okay? It has the same initial value and the same let's see, the same asymptote. Okay, so based on the graph there, you can see how those changed. All right, last question. If the pre-image f of x is transformed using the mapping statement f of x mapped to f negative x, describe what the graph of the image looks like and explain what is happening here. So let's go and do that. And instead of x over 2, let's put a negative x in there and graph that. Whoa! All right, so the blue graph is our initial graph. The red graph is the negative x. And as we can see here, it's a reflection about the y-axis of that initial graph. So that's pretty cool. The image is a reflection of the pre-image. and it's a reflection in the y-axis. Okay. The image is decreasing versus increasing, which would lead us to believe that the number of people sick is decreasing. People are getting better. Okay? So again, when we put in that negative x, we ended up with a reflection. I really like this tool of using a graphing calculator to decipher what's going on with these. For me, and I think for a lot of us, just having that image is a really powerful tool versus just trying to decipher it via words. So I would encourage you to keep doing that. Thank you for joining me, and I will be back for lesson 25.